Your next topic is what? Beta function. We finished gamma function. Now we will have beta function. What is the beta function? Just we define the beta function. Then we will go for the problem based on that. So beta function. Beta function. What is the beta function? So let us see the definition. The definite integral. The definite integral of limit 0 to 1 x raised to m minus 1 into 1 minus x raised to n minus 1 dx where m and n are positive integer is called beta function. Is called beta function. Is called beta function. Okay. It is denoted by a symbol. It is denoted by symbol beta of m n. Okay, and it is a function of parameters m and n where m n are parameters. Okay, so this is simple definition of beta function. Now trigonometric form of beta function. What is the trigonometric form of beta function? So we will have trigonometric form of beta function. Form of beta function. Okay. See here. The trigonometric form of beta function is defined by like this. Trigonometric form of beta function is defined like this. This is what? Beta of mn, and this equal to what? 2 times of integration of limit 0 to pi by 2 sine 2 m minus 1 x into cos 2n minus 1 x dx. This is the trigonometric form of beta function. Okay. Now you can prove this, the result. If I consider the beta function, consider the beta function beta of m n, and this is what? Beta of m n. Now just we define integration of limit 0 to 1 x raised to m minus 1 into 1 minus x raised to n minus 1 dx where m n are positive integer. Okay, this is just we define the beta function. Now what? If I use substitution, we put here x equal to sine square theta. You can also put x equal to cos square theta. Okay, so just differentiate this. So you will get dx equal to 2 sine theta. So we're differentiating with respect to theta. So 2 sine theta into cos theta and write d theta. Okay, so whenever you will use substitution, just change your limit. So when x equal to 0, so this implies that when x equal to 0, so this implies that theta is also 0. So theta will 0. Okay. When x equal to 0, then theta will also 0. And when x equal to 1, so this gives theta equal to which value of sine give 1? That is pi by 2. Pi by 2. Which value of sine gives 1? Sine. So that is pi by 2. Okay. So when x equal to 1, then theta will be pi by 2. Now substituting all this value here. Therefore, we will have therefore beta of mn and this equal to, just substitute all the values. So a limit change from 1 to 0 to 1. So 0 to 1 change from 0 to pi by 2. 0 to pi by 2. So instead of x, we write here sine square theta raised to m minus 1 into, here we write 1 minus sine square theta. The power is what? N minus 1. Getting? And dx, instead of dx, we write 2 sine theta into cos theta and d theta. So just simplify this. This is equal to 2. 2 I'm writing outside. So this is the constant we taking outside. So integration of limit 0 to pi by 2. 0 to pi by 2. This is what? Sine square theta, the raised to m minus 1. But 1 minus sine square theta can be written as what? Cos square theta. It is correct. N minus 1 into sine theta into cos theta. And we write d theta. Okay. And we will write d theta. Now what happened? Now what happened? See here. This is what? This is sine square theta and cos square theta, but sine is here, 1 cos is here. So we will get 2 integration of limit 0 to pi by 2. This can be written as sine. This is multiplication. This become 2m minus 2. Okay. This will multiply this power. And here we write theta into cos 2m minus 2 theta into sine theta into
That's close
cos
to.
theta. Just wait. So this can be written as 2 times of integration of limit 0 to pi by 2. And देखो the power is 1, so एक power यहाँ से कम हो जाएगा. So this is what? Sine 2m minus 1 theta into cos 2m, sorry, cos n है ना. So this is n. Just write on n. So this is cos 2n minus 1 theta and d theta. Okay. Now again we change the power. If I put here, let us move for the next page. Now if I put here, putting 2m minus 1 equal to p and 2n minus 1 equal to if q. If I put 2m minus 1 equal to p and 2n minus 1 equal to q, that is just change the order. That is what? M equal to what? P plus 1 by 2 and n equal to what? Q plus 1 by 2. Then what happen? Then we will have beta of mn and this equal to, just go for this integration of limit 0 2 times of integration of limit 0 to pi, 2 times of integration of limit 0 to pi by 2, not pi, 0 to pi by 2, and this is sine p theta into cos q theta and d theta. Okay. Now, therefore, this can be written as integration of limit 0 to pi by 2 sine p theta into q theta, sine p theta into cos q theta and d theta, and this is equal to what? 1 by 2 beta of m n. Okay, 1 by 2 beta of mn. Now instead of m, we put this, instead of n we putting this. So just write down, therefore integration of limit 0 to pi by 2 sine p theta into cos q theta d theta, and this equal to 1 by 2 beta of m. M is what? P plus 1 divided by 2, or n is what? Q plus 1 divided by 2. Okay, so this is your formula we will use while evaluating the integral. Okay, you must have to remember this is your important formula. Okay, so please remember this. We will take the example which is the very important for you. Example, so prove that prove that beta of mn equal to integration of limit 0 to infinity x raised to m minus 1 divided by 1 plus x raised to m plus n and dx. Okay, we will prove this result, and this result is important for you. So for this, what I have to do? So here proof, or you can say solution proof. So how to prove this result? So consider the integral. We considering first right hand side. Okay, so integral of limit 0 to infinity x raised to m minus 1 divided by 1 plus x raised to m plus n and dx. Okay, here. So please observe that. What I have to do over there? So here 1 plus x. Okay, so you know the formula of sec square theta equal to 1 plus tan square theta, like that formula, or sec square minus tan square theta, sec square theta minus tan square theta equal to 1. Okay, so this is the relation of some tan. This is the relation for tan. So we put here x equal to tan. If I putting x equal to tan square theta, then we can solve this problem easily. Okay, or you can put also x equal to, if you don't want to put x equal to tan square theta, then or you can put here x equal to t by 1 minus t. If you are putting this, then you can also able to solve this problem. Okay, so we just putting x equal to tan square theta, then we differentiating this, so we'll have dx equal to 2 tan theta and sec square theta d theta. Getting? I'm differentiating tan square theta, so you will get 2 tan theta into sec square theta d theta. Now whenever you will use substitution, just change the limit. So when x equal to 0, so this implies that theta will be what? If x equal to 0, then theta will be 0. Okay, and when x equal to infinity, so you will get theta equal to what? Theta equal to pi by 2. So now change the limit. So you will have integral of limit 0 to infinity x raised to m minus 1 divided by 1 plus x raised to m plus n and dx, and this equal to, I am writing here 0 0, your limit change from 0 to infinity to 0 to pi by 2, so 0 to pi by 2. So instead of x we putting tan square theta the whole power m minus 1 and divide by 1 plus x. X is what? X is tan square theta the whole power m plus n, and instead of dx we write here 2 times of tan theta sec square theta and d theta. Okay, just simplify this. uh, just simplify this, so you will get 2 is constant term we taking outside, so 2 times of integration of limit 0 to pi by 2. So just solve this, so you will get on the numerator tan 2m minus 2, okay, and theta into tan theta into sec square theta and d theta, okay, and divide by denominator 1 plus tan square theta is what? Sec square theta, and the write down the power m plus n. Okay, now just solve this, so you'll get 2 times of integration of limit 0 to pi by 2, and this is what? 1 tan is here, so this will what? Tan 2m, or power is 1 here, so 2 minus 2 and plus 1, yeah, how much? That is minus 1 theta, and here sec square theta as it is. What happening here? Sec square theta we write as it is, just write down sec square theta and d theta, and this can be written as what? Sec 2 times of m plus 2 times of n theta. Okay, now we will write this as, so what is the sec square theta? We write cos square 1 upon cos square theta, so just write down, so this equal to 2 times of integration of limit 0 to pi by 2, but what?
Sir, tan theta.
हाँ देखिए, tan 2m minus 1 can be written as sin raised to 2m minus 1 theta by cos 2m minus 1 theta. We can write like this. Yes or no? Then
Yes, sir.
then what? Then this can be written as what? This we write here 1 upon sec, that is cos. 1 upon sec, that is cos. So we write 2m plus 2n theta into what? And sec square theta can be written as cos square theta. Just we writing this. Okay, sec square theta can be written as what? Cos square 1 sec square theta can be written as 1 upon cos square theta. So this is 1 upon cos square theta and d theta. Is this correct? Yes or no?
Yes, sir.
Yes.
Okay. Now what? Now this can be written as, just go for next page. So therefore integration of limit 0 to infinity x raised to what? M minus 1 divided by 1 plus x raised to m plus n and dx. Okay, this equal to, we write 2 times of integration of limit 0 to pi by 2. Okay, so we write here sine raised to 2m minus 1 theta, sine raised to 2m minus 1 theta into, we write cos. Okay, what is the power of this? Cos 2m plus 2n theta. We just write 2m plus 2n. Here we write theta. Then next term is what? Next term is, this can be written as cos raised to minus 2 theta. Okay, so this can be written as into cos raised to minus 2 theta. Okay, and the next term is what? Next term is this one. Okay, so this can also be written as cos raised to into cos raised to minus, what is that? Minus 2m minus 1, minus 2m minus 1 theta and d theta. Okay, so this can be written as 2 times of integration of limit 0 to pi by 2, 0 to pi by 2, and here sine 2m minus 1 theta into cos, base are same, so power will be added. So we write 2m plus 2n, we write theta, and minus 2, multiply this, so minus 2m and minus minus here plus 1. Okay, and d theta, so this gives 2 times of integration of limit 0 to pi by 2 and sine 2m minus 1 theta into cos. So here this 2m and this 2m cancel. What is the remaining? 2n minus 2 and plus 1, that is minus 1, and theta and d theta. But we know that this is what? By the last lecture, this is what? This is the simply beta function. This is what?
Beta
Beta
function.
function. Yes, this is beta function. So we write here beta of m n. Okay, hence proved. So thus we can write down, thus integration of limit 0 to infinity x raised to m minus 1 by 1 plus x raised to m plus n and dx, and this is equal to what? Beta of m n. Hence prove this. Hence proved. Okay, I hope you understood this problem. Yes or
Yeah.
no? Huh. Now similarly you can also prove that. Example number 2. Example number 2. Okay, prove that beta of mn equal to integration of limit 0 to 1, 0 to 1 x raised to m minus 1 plus x raised to n minus 1 divide by, whole divide by 1 plus x raised to m plus n dx. Okay, you can prove this also. So for this, what I have to do? Either you separate this or don't separate. By putting x equal to what? Tan square theta, you will get this result. You will get this is equal to beta of mn. Or just simply put here x equal to 1 upon t. Okay, you put x equal to 1 upon t, then you will get this result. Okay, so this is exercise for you. So please do this problem at your home. You have to put x equal to 1 upon t. Solve this.
Yes.